Good afternoon, guys. It is February 11th in Skull Valley right now. And I want to talk about one of the most forgotten ecosystems of the Intermountain West, the Playa lakes, or the dry lakes, as they might be more appropriately called, or the alkali sinks, depending on if they have certain characteristics. I'm talking about, broadly speaking, the flat, barren expanses that sometimes retain moisture at the bottoms of valleys in the basin and range region, or I should say the basins in the basin and range region, such as I said before, Skull Valley right here. Now, these are an important yet oft forgotten ecosystem out here, I believe, due to remoteness and their apparent sterility, because they are a very, very tough place for life to flourish. But they are unique, at least in the United States, to the western United States, in particular in the very arid areas such as here. And they really over existence of the general landforms, geologic history, and climate of the region. So starting about, actually I don't have no idea how long it started, but with Western North America's continental crust spreading apart in the basin and range region, what happened was that the crust broke apart into different blocks that folded and stretched, creating high mountain ranges like the Stansbury in front of me, or the Cedar Mountains, I believe they're called, to the east, a lot shorter, as well as broad valleys, which, as this was stretching and folding has happened, and as soon as these mountains started to rise up, began filling with erosional sediment from them. Rivers began to carve them out and deposit sediment all throughout these areas. So in some places they end up being thousands of feet thick with sediment, and instead of being deep valleys that go below sea level, they end up being broad, flat areas that are more appropriately called basins. Now, because of the nature of erosion, the sediments that tend to accumulate the most right at the center are the finest erosional material, so very fine dust and clays and dissolved salts. But because these areas tend not to drain to the ocean, these salts and alkaline clays just accumulate here very thickly, leading to these harsh, alkaline, often saline regions where few plants can grow. And one of the reasons why these things don't ever drain to the ocean has a lot to do with the aridity of the region, because these sort of, as they're called, endorheic basins, those are basins that are, it's getting really muddy here. Oh boy, that kind of, it's not quite clay, but it's very, very fine sediment getting stuck. It makes a really nasty mud. It gets stuck in your shoes and on your pants and everything. But I should have brought my wading boots. But anyways, the sort of nature of arid areas is that evaporation is greater than precipitation. So if we're just a normal place with a normal, more mesic climate, what would basically happen here instead is that water would continue to pile up and up and up until it found a place to overflow, perhaps into a different basin, but eventually into the ocean, which is what happened with Bonneville Lake during the last glacial period. That was a time when the climate was more dominated by precipitation than evaporation. So through Red Rock Pass, Lake Bonneville poured, but before it got to that point, it got quite large, up to about 30,000 square miles in area. And if we entered the number of wet bays, that's what would happen here too. The lake level would just rise and rise and rise until it found a way to get to the sea. It's just sort of the nature of the game, because think about it, if there's less less evaporation precipitation, water naturally has to accumulate unless it's draining through some subterranean thing or whatever. Anyways, of course I should say that, so at Sun Lake there was a lot of precipitation across all the world's arid areas, because there is quite a lot of endorheic basins in the world. To take up about a fourth of the world's land surface, there'd be a lot of lakes very soon, but it wouldn't last forever because intense erosion would lead to their levels generally lowering, which is what also happened at Red Rock Pass. There was a gigantic flood as the water level, or as the what was holding back Lake Bonneville gave way, and a massive flood over a course of like a year or so flowed into the Snake River, permanently lowering the level of Lake Bonneville from thereafter and into the future. That aside, I mentioned before that ecologically speaking, these areas are considered pretty sterile, at least to the casual observer, and to be honest, they're not wrong. I mean, just look at this. Very few things can grow out here, despite the fact that it would supposedly be not too bad soil, or at least might appear that way, and it gets a lot more water in the form of runoff than most of the desert areas out here do. But this can be deceiving because, as I said before, a lot of this is just really fine alkali clay particles, as well as dissolved salts that make it really hard for plants to pull moisture from the soil, even at times like this. So you really only get a few plants surviving out here, such as this Allenrolfea occidentalis, which I christened in a previous video, the toughest plant in the western United States, and for good reason. It's one of the few plants that can handle soil this salty. The only thing it really kind of likes is to have a bit more moisture than other desert plants, but it might as well be watered with seawater. Sorry, it might as well be watered with seawater the way it lives. And of course it can handle intense heat as well as frost. It can really handle almost everything. But some places get even too harsh for this plant. Like if we head further out there, we're going to see that there's nothing even growing out there. But of course there are other plants that can handle these kinds of environments, not just in the western United States, but all over the world, because this really is a bit of a global ecosystem. Or not just say ecosystem, a global habitat type. You can find them on all 5 major continents, and of course I'm excluding Antarctica because it's kind of irrelevant to a lot of these discussions, as well as Europe because it's basically part of the broader Eurasia region. But you can find them in southern South America. They serve in the high Andes, moving southeast into Patagonia. Find ecosystems like here, and actually just quite a good diversity of plants that are endemic to that region. You can find them in southern Africa, in that arid region like in the Kalahari, or in the Mid and Karoo regions. You can of course find them in Australia, which I think it's a good time to mention that these places exist in both hot and cold deserts. If you didn't know that, there are hot and cold deserts, like hot like the Sonoran Desert, but also cold steppe-like ones like the Great Basin, which I'm in right now. This sort of habitat and on a global scale exists in both of them. In Australia though, there's really only hot deserts. But I think the biggest, most notable place you can find this is all throughout the Great Arid Belt of Eurasia. Because there's a gigantic arid belt that runs from the Sahara Desert from the Atlantic coast all the way through the Middle East into Central Asia, the steppes are, and then through the Gobi Desert, almost all the way to the east coast of China. It's a gigantic, the largest area of contiguous desert in the world. And of course there's quite a few basins where these sort of some dry and playa lakes can develop, not to mention the adjacent salt brush, because there's a bit of zonation here as well, where I had to move a little bit higher in elevation to areas that had a bit more forgiving soil, less constant inundation, and just less salt overall, just better conditions. You'd find a host of plants that are adapted to high salinity, halophiles as they're called, which means salt-loving, although they don't exactly love salt. They sort of just put up with it because they need to. And it was a niche that was available for them. But as I was saying, you can find all those plants there, like the shad scale, Achiplex convertifolia, Achiplex canescens, which is a forming salt brush, lots of tetrademias, Sarcobatus vermiculatus, or greasewood, which is, again, one of the most salt-tolerant plants you can find out here, and a whole bunch of others. I could go on all day. It's not exactly a super biodiverse ecosystem, but the whole presence of this sort of continuum, this salt desert to dry lake and salt flat continuum, definitely increases the biodiversity of the Mountain West, even though the local diversity is low. I'll just ram this home. Local environments that are hard for plants to live on can foster endemism, and although they won't typically be very biodiverse on their own, they overall increase the biodiversity of the entire system. I can see here that nothing is really growing out here. I suppose it is possible that Allenrolfea occidentalis could grow out here, but I think it's just a little bit too harsh. And that's really just a story of these dry and playa lakes. Now, of course, the fact I say dry lake implies that they are wet sometimes, which is true, at least ephemerally. So in response to local recent weather, they can sometimes fill with water or at least get damp like this is. Though some of them do get seasonally wet, so like we might be wet for a few months in response to a rainy season. That tends not to be the case out here, but frankly there is, I don't know where I was going at that point. Sorry, I think I'm doing this all in one go. I hope this comes out all right. I certainly want to revisit this and talk about these ecosystems more, and I'm sure I'll repeat myself a lot over the course of this channel's history. But anyways, yeah, this is a dry lake, or as we call it in the western United States, a playa. A unique ecosystem that you're not going to find anywhere else in the country. I mean, you can find them in other parts aside from Skull Valley, but it's really all in the western dry United States. All right, one other thing I did forget to mention is that though I did say these places were apparently sterile, there might be a little bit more of it meets the eye because in times when these things are wet and inundated with water, algae can thrive, which can then support various crustaceans and insects, many of them too small to be seen with the naked eye, but are no doubt here, or at least other species of bacteria, and perhaps birds that might feed upon the algae or little crustaceans. There really is a lot of life out there if you know where to look. There's a diversity of sort of saltwater shrimp in the western United States and bugs. There's a spider that lives on the margin of salt flats, and more in the Mojave and parts of New Mexico. I want to hopefully find out when I go to Death Valley later this year. But I really hope this turns out well, guys. I'm a bit rusty, but I'm really trying to practice and get back into making videos because it's winter. I don't think it's an excuse not to talk about anything. But yeah, thanks for watching and see you next time.